Hey guys, today we're going to discuss molarity. We're going to extend it further and look at answering questions where maybe the question directly isn't asking for molarity, but rather derivatives of molarity. And so we're going to take a real good look at those type of questions. Now, in order to answer some of these questions, there has to be some established prior knowledge, and that comes with any kind of chemistry, obviously. Now, this first question here for exercise 4, it's tasking us with calculating the number of moles of chloride ion in 1.75 liters of 1.0 times 10 to the negative third molar zinc chloride. Now, in order to effectively solve this question, I would recommend writing the basic chemical equation in order to solve it. And so to do that, you have to understand the chemical makeup of what zinc chloride is comprised of. It is comprised of zinc plus 2 ion and chloride anion. Remember, there are 2 of them though. So we have 1 zinc, 2 chloride ions, and what that means is because there's 2 chloride ions, whatever the molar concentration is of this guy is, it actually gets doubled on the opposite end. So 1.0 times 10 to the negative 3 here, molar, remains the same for just zinc 2 plus, but this concentration doubles here. I'm going to put a star here because it's important. And it becomes 2.0 times 10 to the negative third power. Because there are 2 of those guys. And so, if I was representing the math, basically 2 times whatever the molar concentration of that solution is how we get that number there. So knowing that, we're now going to use our known molarity and our known volume to determine the moles of chloride ion. Now, the generic equation for molarity is that molarity is equal to moles of solute over liters of solution. And I'm abbreviating solution. However, we're tasked with finding the moles. Rearrangement of that equation yields the following. Moles is equal to the molarity, which I'm representing that big M for molarity, times the liters of solution. And so then I'm just going to effectively plug and play. I'm going to take my known molarity of the chloride. Remember, this is chloride, so that's actually going to be 2.0 times 10 to the negative 3 molar chloride ion, and we're going to multiply that by the liters of solution, which in this case is here, this 1.75 liters. And when you multiply those 2 together, you end up getting 3.5 times 10 to the negative 3 moles chloride ion. Now, it's important that in order to solve this, you understand that zinc is the host compound, but its charge balancing, when it's broken down into its ions, you have to understand that there are 2 chloride ions and 1 zinc ion. And so because there are 2 chloride ions, this actually multiplies the standard molar concentration, and that becomes 2.0 times 10 to the negative third. And then you plug that here for molarity, multiply that by your volume of liters, and that will yield your moles. And so that's how you solve for that. Now let's look at exercise 5. Here it talks about typical blood serum being about 0.14 molar sodium chloride, and it's asking us what volume of blood contains 1.0 grams of sodium chloride. And so to solve this, we are looking for the volume. That's what we are solving for, which means we are going to need to know the molarity, and we're going to need to know our moles. Now, we have our molarity. That's our molarity there. We have our milligrams of sodium chloride. Now, milligrams can actually be converted to, I think I said grams earlier. It is milligrams. We can convert milligrams to moles of sodium chloride. Now, to do that, you're going to need to first convert milligrams to grams and then kind of convert from there. All right, to do so, I understand that 1.0 milligrams of NaCl. I'm going to convert that using factor label method, and you need to know that basically 1,000 milligrams is equal to 1 gram. So knowing that, I'm going to say that 1,000 of these guys is going to be equal to 1 gram, which inadvertently means that you're just dividing 1 by 1,000. So 1 divided by 1,000 yields 0.001 here. Switch 0.1 grams of NaCl. I need to convert that to moles. I take that and I divide by the molar mass of sodium chloride. Remember, you get the molar mass of a compound using the periodic table. Sodium is roughly 22.9 or something like that, which rounds to 23. Chloride is like 35.45. And the molar mass ends up being 58.45 grams for NaCl and 1 mole of NaCl. So I'm going to take that 0.001 and divide it by the 58.45, and that's going to give me my moles of substance, or sodium chloride solute, rather. And that's roughly 0.00, that's a lot of zeros, 0.17. We'll round it to that. And that's just so you can kind of see it. But we're going to round it to that. And that's our moles of NaCl. So we know our moles. We also know our molarity. According to the rearrangement of that equation, if we are solving for our volume, which is going to be representative of liters of solution is going to be equal to the moles over molarity. And so I'm just going to essentially plug in my numbers where I know that 0.00017 moles of NaCl is going to be divided by my 0.14 molar concentration of NaCl. So 0.000017 divided by 0.14. Alright, the number I get is something like this, which is equal to 0.00012, and that's my liters of solution. And if I want to convert those to, I don't know, scientific notation, that would be equivalent to 1.2 times 10 to the negative 4th liters. And to make it comparable with the answer that they give here, I could actually just multiply by 1,000. And that's equal to 0.12 milliliters. So all of this checks out. And that is how you solve a molarity-based question when you're dealing with trying to solve for one of the other variables, such as liters or perhaps even moles.